rapid access to comprehensive oncology data and survival analysis. This is the Enko Toolkit.
You're in a busy clinic. Time is the one thing you don't have, and clinical risk is staring you right in the face. You need answers, and you need them to be instant, streamlined, and evidence-based. Well, today, we're diving into the tool that delivers exactly that for managing brain metastases, the Graded Prognostic Assessment. So let's get right to the heart of the problem we're tackling. It's that high-stakes, daily challenge of accurately stratifying patients who have brain metastases. It's a decision you have to make constantly. And the scale of this problem, it's huge. We're talking about roughly 1 in 4 of all cancer patients. They will develop brain metastases. So this isn't a rare occurrence. It's a frequent, critical decision point, usually when you're under a ton of pressure. Now, what makes this so incredibly tough is just how different these patients are. It's a hugely heterogeneous population. And that's why getting an accurate survival estimate isn't just a nice thing to have. It's absolutely essential. It's how you individualize care. It's how you make that critical call. Do we go down an aggressive treatment path, or is a palliative approach more appropriate? Ultimately, it's about avoiding futile interventions. Okay, so how do we possibly bring some order to all that complexity? Well, the answer lies in the Graded Prognostic Assessment, or GPA. Let's pull back the curtain and demystify this evidence-based score. The Graded Prognostic Assessment, the GPA, is a quantitative index, and that word is so important. It's a huge step up from older, more subjective systems that really relied on, clinical gestalt. The GPA is built from the ground up to give you an objective, data-driven survival estimate. And the real power of the GPA is its beautiful simplicity. It's all calculated using just 4 key clinical variables, which you can see outlined right here. First, we have age. Then, Karnofsky Performance Status, or KPS, which, as you know, is a standard way to measure a patient's functional ability. Third, the number of CNS metastases. And finally, whether or not there's any cancer outside the brain. This table shows you just how elegant this system really is. Take a look at how each of those 4 factors we just talked about gets scored. For example, a patient under 50, they get a full point for age. A patient over 60 gets 0. The scores are simply added up, and that gives you a final GPA somewhere between 0, the poorest prognosis, and 4, which is the best possible outcome. And you can trust this tool because its credibility is absolutely rock solid. This isn't based on some small, single-center study. No way. The foundation is this landmark 2008 paper by Sperduto and his colleagues. They analyzed data from nearly 2,000 patients across 5 major RTOG randomized trials. The evidence here is just incredibly robust. And here is the clinical payoff. This table shows you the direct link between that GPA score and median survival. And look at the difference. It's stark. A patient with a low score, say 0 to 1, has a median survival of just 2.6 months. But for a patient in that best prognostic group with a score of 3.5 or higher, that number jumps all the way to 11 months. This is the kind of quantitative data you need to have those really tough conversations. Now, it is important to point out, this is the original GPA. It's the foundation. The field, of course, has evolved, and now we have more nuanced, diagnosis-specific GPAs, the DSGPAs. These start to incorporate molecular markers for specific primaries, like lung, breast, or renal cell. And don't worry, we'll cover those in a future explainer. So, we've walked through the science. Now for the fun part. Let's see how the Enko Toolkit app takes all that evidence and turns it into instant, streamlined decision support right there at the point of care. And here it is, live in action. On the left, you've got this super simple data entry. You just select the values for those 4 variables we discussed. And boom, in seconds, the app does the math and gives you the score right there on the right. An instant, evidence-based survival estimate. No more guesswork, no more hunting for reference tables. And this is a principle we take very seriously. We don't believe in black boxes. The math and the reference tables are right here for your review. Because transparency, that's the key to clinical trust. And we don't just say that, we show it. Inside the app, this formula logic section isn't buried somewhere. It's right there, showing you the simple sum of scores calculation, so you can trace exactly how your inputs led to that final result. Total transparency. Getting this result instantly really changes your clinical workflow. You can immediately stratify a patient's risk. This means you can have much more informed, data-driven discussions with patients and their families right then and there.
It gives you that quantitative framework you need to confidently triage patients, backing up your clinical judgment with hard evidence. But the tool's utility doesn't stop when you walk out of the exam room. It's actually designed to build a bridge between your clinical data and your academic research.
So every single calculation you run can be saved. You can even add an optional patient identifier for your own records. Then, from this saved results screen, you can export your entire cohort's data with just one click into a research-ready CSV file. And let's be crystal clear about this. This data export is designed for one thing and one thing only, to be a bridge to deeper research. It's a flattened file ready for your stats software. It is not for EMR integration.
Think of this export as your entry point into a complete research ecosystem. It's designed to power your whole workflow, from the data you just collected all the way to your next big discovery.
The entire research workflow is designed to be incredibly simple. We've broken it down into just 2 steps. Step 1, prepare the raw data you exported. Step 2, run your analysis. Let's see what that looks like. Step 1 is the CSV polisher. Now, any researcher watching knows that data cleaning can eat up so much of your time. This tool automates all of it. It handles missing values, it correctly formats your categorical variables, it just makes sure your data is perfectly prepped for statistical analysis, and it does it in seconds. And step 2 is our survival analysis tool. You take that polished CSV, upload it, and it automatically generates publication-ready Kaplan-Meier curves, chi-square tests, log-rank stats, hazard ratios, the whole shebang. It literally turns your raw clinical observations into powerful academic insights. So all of this brings us to one final thought. We've seen how a transparent, evidence-based tool can streamline your clinical decisions and power your academic research. So the real question for you is, how could something like this transform the balance you strike every single day between your demanding clinical practice and your drive for meaningful research?